Theoretical recap. In the previous workshop, you built a Python script that executes the ping command using the subprocess library and saves the output to a file. That script worked, but it used a hard-coded default number of packets, meaning you had no control over how many ICMP requests were sent. In network reconnaissance and security auditing, controlling the packet count matters. Too few packets may yield unreliable results, while too many can trigger IDS/IPS alerts or saturate a network link. The subprocess.run function accepts a list of arguments that maps directly to a command line call. For example, subprocess.run ping C4 192.168.1.1 on Linux/Mac OS sends exactly 4 packets. On Windows, the equivalent flag is an A. This means your script must detect the operating system at runtime. The platform or sys module can help here and adapt the flag accordingly. A common mistake is hard-coding the packet count as a string directly in the script without validating user input, which can lead to runtime errors or, worse, command injection risks if the value comes from an untrusted source. Always validate that the input is a positive integer before passing it to subprocess. Another frequent error is forgetting that subprocess.run arguments must all be strings, not integers. Always cast your count with str. Mini example, count equals str int user underscore input, followed by subprocess.run ping C count target is the correct and safe pattern. Workshop brief. This workshop builds directly on the previous one. You already have a script that pings a target and saves the output. Now you will extend it so that the number of ping packets is configurable at runtime, either through command line arguments or user input. This is a small but critical step toward writing reusable, professional-grade security automation scripts. Your script must accept a target IP or hostname and a packet count as inputs. It must validate both values before executing the command. The target must be a non-empty string, and the packet count must be a strictly positive integer. If validation fails, the script must display a clear error message and exit gracefully without crashing. Use the exception handling patterns you studied earlier, try/except, value error, system exit, to handle bad input robustly. The script must also handle the cross-platform difference between Linux/Mac OS, C-flag, and Windows, and flag. Use the platform module to detect the OS and select the correct flag automatically. This makes your tool portable, an important quality in a DevSecOps context where scripts may run on different environments, local machines, C pipelines, Docker containers. Once the ping command runs successfully, save the full output to a timestamped log file. For example, ping_result_2024-11-15_143000.txt in a log/directory. If the directory does not exist, create it programmatically. Use the OS module for directory handling, and make sure your file writing code uses proper exception handling to catch permission error or OS error. Structure your code with at least 2 functions, one for input validation and one for executing the ping and saving results. Finally, add a proper docstring to each function, following the conventions covered in the documentation chapter. Your script must be importable as a module without side effects. Wrap the main execution logic in a if_name_equals=_main_. Guard. Test your script with at least 3 scenarios: a valid target with a valid count, an invalid packet count, for example, -3 or a.b.c.', and a valid target that is unreachable. Document the results of these 3 tests in a short readme.md file, 5 to 10 lines, that explains how to run your script and what each argument does. You have 3 hours to complete this workshop. Submit your solution, the Python script and the readme.md, before the deadline expires. You are free to consult all previous course materials, official Python documentation, and any internet resources. You may work alone or ask for help, but the final submitted work must reflect your own understanding.